Okay, last time we started creating a little bracket, and I wanted to take you through all the tips and tricks that I used learning and getting used to OpenSCAD, and how to use that. And then eventually at the end of the series, I'll also touch on SketchUp, because there's a couple of brilliant videos on YouTube on how to use SketchUp. So I'm not going to take you through all the detail. You can probably find way better videos than mine. But I do want to just touch on the system modeling aspect as opposed to the component level modeling that I think OpenSCAD is pretty good at. Okay, so let's continue on from where we were. So what we have effectively here is three separate bits, right? And what we want to start using is now to cut out the little holes for the screws and the mounting brackets and the screws, and also the cutouts for the tools to get through and that kind of thing. So to do that, we use a method called difference. So what difference does, if you add a difference method in the top, okay, and we'll say take everything from there to the end, indent it, and do that. How that works is difference assumes that your first object is the object you want to place, and every object after that it will remove, right? So it'll place that one and cut these shapes out. So if I press F5, well, you really can't see anything. If I press F12, you'll see that only the first cube or cube method is there, and the rest is cutouts from that cube. So if I have to do a full render and I press F6, that's the object you're going to get hold of, right? So to combine all of these shapes that we have done so far into a single shape, right, you'll want to use a union method. So union, and there's your okay, and you'll indent the whole group and close your bracket. So now if I press F5, you'll see that we're back to a solid shape. The bonus, however, now is that we can now start cutting out the holes, right? So anything beyond the union statement is going to start getting cut out of the shape, right? So let's start with a cylinder for our screw holes, and a cylinder takes a couple of parameters, right? So let's say the height is equal to thickness, right? So we want to cut a cylinder out of this guy that is, we're going to cut through the thickness of the shape. So what I like to do with cutouts is to make them just a slight bit bigger than the actual object I want to cut out, so that you don't have two planes ending on the same level and then the software having to choose which one stays and which one goes. So I generally would go ahead and make the holes just a tad bit bigger than what they need to be. Sorry, the cylinder, the cutout slightly longer. So think of this as your drill being longer than the actual hole you're drilling. We need a radius equal to, and we had a variable called the hole radius. Right, so I said that. OpenSCAD then has a thing called a $FN, a function, and I like to run at 100. So what this means is it will take any circle, cylinder in this case, and it will break it up into 100 segments. So for instance, if we add a circle and we put 360 in this value, you'd have one flat side per degree of the circle. I find that 100 is a nice even number where you get good quality circles, while they and they're fairly printable. So this is useful for when you want to do six-sided. So if you want to do a hexagon, you'll place 6 in that value, and it'll cut a little, it'll make a cylinder with 6 sides to it. 100 sort of still looks like a circle, but it doesn't take too long to render the whole thing out. Okay, so, and lastly, what we want to add there is center equals true, because we like our things. Oh, sorry, I missed a comma. F5. Let's just go back to F12 view. Okay. So where's our little cylinder? There we go. He is centered, and as you can see, it's green. So what green means is that that part's going to get cut out. So if I do a full render on that, you'll see that you end up with a little hole there, right? Remember, our cylinder is still fully centered, so it's in the middle there. So now what we want to do, obviously, is move this to the right place on our model. So as we saw last time, the best way to move something is to use a translate method. Remember to indent it correctly to preserve your readability. Okay, so translate, and we want to translate this guy. Okay, so where do we want these holes? We want these holes to, I want two holes, right? So the best way I can see that is to take your length, or your height width variable that we had earlier, and divide that by 4, so we get the quarters, right? So for the first hole, we'd want it to sit right there. Right, so what have we done? If we take a look at this guy, we have taken our length, divided it by 4, right? So our hole should sit roughly there, and we have moved it in the X direction, so it'll sit over there. So let's render this guy. I'm going to go back to all values, F5, and there's our first hole, right? So now we want to do exactly the same thing again, but we want to put it in the third quarter, right? So we can do exactly the same thing. You can times this by 3, F5, and there's a hole, right? So this is one of the reasons why I multiplied the thickness by 2, is so that we can get past our 45-degree brace there. All right. So now we want to do the same thing again, but for the upright. Okay. So to do that, we can literally make a copy of these guys, because they work perfectly fine as they are. However, we want to rotate the last two by 90 degrees based on the center that we had. Control I, enter, tab, yes, and we want to rotate these guys around the Y axis by 90 degrees. Okay, so let's see what happens. Right, nothing happens. The reason nothing happened is because I'm rotated these 90 degrees in that direction. Because it doesn't intersect with anything, there's nothing for it to cut, and therefore it simply doesn't show it. So if we change this to minus 90, F5, and we're done. There's a hole. If we do a full render of this, F6 by the way, does that, you'll see there's a hole. So this is just about ready to go, with one little exception, is that we can't get a screw in there. And even if you could get a screw in there, there's no way to get a tool in there to actually tighten it up with. So let's then move along and say, right, so let's do the cutouts for the tool shapes to get through there. So again, the way I do that is we'll start with a cylinder. Okay, let's get that slightly up. So a cylinder, remember to any command that you give it as opposed to a command that acts on something else. Every actual object command has to end in a semicolon. So if we now want to put a slightly thicker cylinder, because obviously remember now our not only the screw has to fit through there, but the screw normally has a slightly bigger head which sits on there. It needs to fit through. So what I'd want to do is to say, let's make a cylinder where the height is equal to the same height as the whole tool. Remember, these are cutouts. So at the end of the day, if this is way too big, it doesn't really matter, as long as it's long enough to get through any of the bits we need. Let's make the radius equal to the whole radius times 2. So it's at least twice as thick as the screw you wanna put in. I'm again going to use $FN equals 100 as our let's say quality or resolution, and I'm going to put it as center equals true as a starting point. Okay, let's press F5. We'll see that. That's because we're in final render mode. If you press F12, you get the combined view. Press F5 again. You'll see. Okay, so this is what that kind of looks like, which is not quite what we need. Again, what we need to do now is simply move it around a bit. So, as you should know by now, the way to do that is to use a translate command. Right, and we have our brackets, indent, close our brackets, we have the square brackets inside there, and our three coordinates. So what do we want to do now? So we want to move it on the x-axis the same as we moved that guy. So on x we'll move height width divided by 4. Okay. Let's put these other two guys at 0 just to see what we've done. Moved it there. And what we want to do now is we want to move it up, or on the z axis. So this is the one we're going to work on. So what we want to do in that case is to go with, so let's do height width divided by 2. Okay, and see what that does. That's moved it up nicely, but if we go into our final render mode, you'll see the problem being that height width, that's obviously going to take it up to the center point there, because the length of this thing is equal to height width, and we don't want it. Well, that might be a good option if you want to do a sort of countersunk option, but I think for ours we're going to assume that the screw head sits flush with that thing. So again, what we need to do is we want to add just the thickness divided by 2 to that. Press F5. Okay, again, let's go back to combined view, F12. So that works fine. If we go to final render mode, F6, sorry, rendering sometimes takes a while once you're getting a lot of detail on the model, which is exactly one of the reasons I think it's dangerous to do large systems in SketchUp, because it just eventually gets so slow that it's not usable. So what you'll see now is that rendered correctly, but you'll see that little bit is green. Now the reason for that is because this is what I mentioned last time, where your cut surface and your model surface is sharing a surface there. So you could give this a go and it'll probably work, but you know, I just feel slightly uncertain there. I'd like to be a bit surer. So what I'd like to do there is just add 0.1 millimeters. And if we do a F6 again now, and we let it build, you'll notice that gives us a nice clean lift off the surface. If we go to a combined view and press F5, so F12 and then F5, if we zoom in there, you'll notice that there is this 0.1 units, or if you set up your printer to run in millimeters, there'll be a 0.1 millimeter lift off the surface there. So once we've done that, let's do the same for our horizontal hole, and we'll get to So again, we want pretty much the same setup again. So let's do that. And what we want this time is to just vary things in the other direction, right? So we'll take our x-coordinate, x-coordinate, cut that, take that away, make that our x-coordinate, y remains 0, and z is our height width. And let's see what we get if we press F5. Okay, so not quite in the right, well, I think it's in the right place. I think our issue now is that it needs to rotate. Okay, so let's add, well, let's do it wrong first, so I can just show you the effect. So rotate, I'll come back and fix this. So what do we want to do? Well, I'm going to leave the indentation now, because I'm actually going to show you the wrong way to do this. Well, the way that's not going to work, and then how to fix it. So we might be assuming that we want to rotate this cylinder by 90 degrees to get it to fit in there. So that's exactly what I've done. I've added rotate, and I've added x, y on the y coordinate, right? So that's that line. We're going to rotate this guy by 90 degrees. So if I press F5 now, notice what happens. It's gone, right? And if we go ahead and take that last cylinder out of the difference method, right, by just getting it out of the brackets, and we press F5 now, you'll see that it's sitting down there. Now, why does that happen? The reason that happens is because we've placed the cylinder, which was center. We then translated it away from the center. And it's that translated object, or that moved object, which we are now rotating relative to the center. So remember, it sat out here, right? And we've now rotated all of that by 90 degrees. And that's why it's now sitting outside the model. What we want to do is we want to move this rotate method inside the translate method. So what the effect here is that we want to first rotate it while it's in its center position, and then move it to where it's supposed to be, right? So it's still outside the difference. Press F5 and you'll see it's in its right place. Again, if we look at, see if we can see that gap, it is only 0.1 millimeter. Yep, let me go, I think we can just make it out. Yep, there we go. And you can see that there's just a slightest of a gap. Now you'll see that that is a part of the model that's getting made because it's obviously outside the difference method. So if we put that back inside the difference, press F5, it's turned green. So at this stage, if we press F6, you'll see, so F6 again is the final render mode. You'll notice that once it's rendered, this is now almost a workable bracket, right? You could get a screw in there, you could get a screw in there, you could even fit the screw head through there, as well as a tool to tighten it with, in both directions, and everything's quite nice. So there's a couple of issues with this still. So in the next session, what I'd like to do, as you can see here, this little center bit here is extremely thin, right? So if you try to print that, it would either droop or just not work in the first place, because it is a minute little piece of plastic. As I said, try to make all your pieces of plastic at least 3 millimeters thick, unless you have some of the commercial printers, they might be able to go to that resolution fairly well. But for home-built 3D printers, parts that thin are going to start getting a bit dodgy. The other thing I'd like to do is to add rounded corners to our bit, just to make it look slightly more professional, right? But again, as you can see, all our parameterization still works. If I zoom out a little bit, if I make it 80 long, F5, F6 to get a final render, we'll see that everything is still fine. And we can see everything still works. So in the slightly bigger model, this is actually pretty much ready to go, because that is more than thick enough for us to print it successfully, and stuff will still work fine then. So maybe we should quickly go ahead and just add the rounded corners for now. So to add rounded corners in OpenSCAD, the easiest way to do this, so you could go ahead and generate a cylinder there and a cylinder there, put a square in, or put a square on the outside actually, and then use that as a cutout model on top of this. So another option to do is to simply use a library. Alright, OpenSCAD comes with a couple of libraries, and if you can't find them, have a look on the web. And I quite like this one. If we go to boxes, let me just quickly show you what that looks like. There's a whole piece of OpenSCAD which is predefined for you. You can use those, look at the licenses, everything is good. So if I wanted to import this this library into our render, I'd come here, find the path to where it is, find the path to where it is, find the model, take it. I like using the relative paths, so I know my model is currently in that folder, so because there's where we saved it. Alright, if we come back here and we want to include the library, we could simply do include with the little tags, paste, and OpenSCAD just uses // for that, and we're done. Right, so that's we've now included that library ready for use. And what we could do now is we could simply go and replace our cubes with rounded box. Alright, rounded box has the same coordinates with the rounding radius, right? As well as whether you want it centered. Okay, so the way to look at that is if we come to libraries and we open the boxes model. Okay, so if we have a look at the boxes design, we'll see here that our method that we're going to be using needs size, radius, and sides only. So if we have a look at the example they give us, if we uncomment that, press F5, this is the thing we get. It's 20 by 30 by 40, and the corner radiuses are 5. And true for sides only means that it does not round the top bit. If we make this false, F5, that's the effect, right? Everything is now rounded. So that's how it works, right? So what we want to do is, let's not save our library, only change it to our library. Let's come back to our bracket. We want to have a corner radius, right? So let's put a corner radius equals 2.5, for example, and we want our corner radius in there. We do want it to have only the sides rounded, not the top bits. And we want the exact same coordinates we have there. So copy that, paste, and let's comment out our cube for now. And just press F5. Have a look at what that does. Sorry, go back to combine view, F5. And that didn't work at all. Why does that not work? The rounded box. rounded. Okay, so the reason that doesn't work is because OpenSCAD is case sensitive. If we change that to a rounded box and we press F5 again, there you will see that we've got a nicely rounded little corner there. Okay, and we want to do the same thing with our upright corner, with the upright box. Let's get that over there. So it's height with depth, yep, and that's all fine. Let's comment out that guy, F5, and there we've got our two nicely rounded corners. Okay, so now notice one little problem we have now. Notice that that corner does not look that fantastic. I wouldn't be happy with my part looking like that. So what we need to do is simply add a cube to just fill that back in. So remember, we need to put that inside the union section, and we'll come back and simply put a cube which will be centered, right, and we want to make that to be a 3-part coordinate. So let's have a look if we can work that out. It will be in the X direction. We want it to be the thickness, alright, because we want that thickness. In the Y direction, we want it to be equal to the depth. And in the Z direction, we want it to be equal to the thickness again. And it is all centered, so that should be all we need. F5, and we're done. Right? So there's our first part, guys. That is perfectly usable as it is. If we do a final render on that, press F6, machine clunks away for a little bit, and you'll see that we have a very printable and very usable part. Again, to confirm that it is still fully parameterized, we could change the thickness to 3 and press F6 again. See what that looks like. Now notice that it takes a while because it's re-rendering the entire thing, right? But I'll show you now. So there's a model with only 3mm walls, still perfectly usable, perfectly printable. If we look at it, had a look at this specific model of mine, if we made the thickness 10, I can spot a problem that we might have. Pressing F6, letting it build, you'll notice that our cutouts for our holes are not going to be deep enough. Actually, I think, no, we have taken care of that because we have specified that they have to be double the thickness. So they will always be double the thickness. Right, so that's one bonus for our parameterization. So one thing I wanted to show you, if you put this back to 6, because we've rendered this already, if we do a final render, F6, you'll notice that it renders very quickly. That's because OpenSCAD actually caches the models that it has rendered, and everything still works fine. So next time we'll come back, and we'll do some more work so that we are sure that that little gap between the two holes for these smaller parts actually get cut out. So I'd like to cut that section of the model away as well. And then we'll continue on, and I'll show you some integration with system level design into SketchUp, and how you pull all that together. Anyway, until next time, if you like this video, give it a thumbs up. Cheers.